We are going to add the floating head on the floating tube sheet. Floating head equals bolted domed end. We enter a simple name and description. We move on to the Component Attachment tab. We see that the component attachment is correct on the floating tube sheet at point -239. We move on to the Design Data tab. In the Process Cards Input chapter, there's a very important checkbox that needs attention. In order for vClavis to know that this is a floating head, we need to check the "This is a floating head inside a heat exchanger" checkbox. Once the checkbox is selected, we notice that the process card automatically changes to the Combination of Shell and Tube Side process card. We move on to the Bolted Domed End Data Input chapter. We select Type D for Bolted Domed End type. We check the option Use Bolt Spacing Correction Factor. We can see at the heat exchanger options that the external test pressure increase factor has been automatically filled in at 1.3. For more information, contact support@vclavis.com. We've moved on to the Bolted Domed End Geometry Data Input chapter. We input L equals 315 mm. We input Tn equals 20 mm, Th equals 2 mm. Automatically, thickness after forming is set to 18 mm. Since the floating head is made of carbon steel, we input corrosion allowance on concave side equals 6 mm and 3 mm for convex side. The distance of flange center cannot be input yet because the user has not filled in the flange thickness. We move on to the Input the Flange data. We input A equals 506 mm, B equals 406 mm, C equals 464 mm. We input N equals 20 bolts and flange thickness equal to 65 mm. Having filled in the flange thickness, we can now modify the distance of flange center to head center line. We input 22.5 mm. We move on to the Bolted Domed End Gasket Data Input chapter. We select iron-jacketed mineral fibre from flange gasket material. We select the Include Gasket Pass Partition option. We input the gasket pass partition data. Now we move on and input the flange gasket geometry data. We input 5 mm groove excess thickness. We move on to the bolting data input chapter. We select 3/4 inch bolts from the library. We move on to the bolted domed end material data input chapter. We select SA266 Class 2 for the flange material. We leave the head and bolting material as they are. We fill the bolted domed end with liquid. We click on Calculation Details to save the bolted domed end. Let's check something in the internal pressure calculations. We notice that less than G equals 419 millimetres. Now we will have a look at W and WM1. We exit back to the vessel view. We click on the 3D button to view the vessel. Notice that the bolted domed end is visible. Now we need to recheck the flanged connection in the floating tube sheet. In the flange data input chapter, we modify the dimensions we entered previously. We select the bolted domed end in the channel side. And we see that all the dimensions have been entered automatically. We click on Calculation Details to save our changes. We exit back to the vessel view. Next, we click on Component 28, BR Backing Ring, to create the backing ring.